Good afternoon, viewers. My name is Ogunjimi Isaac Ayobami. I'll be taking you through one of the projects which I just concluded using the Jupyter Lab. The project itself is to run an exploratory data analysis on a terrorist data set based on terrorist attack in different countries. Uh, and why this project is important is because we can gain so many insights, especially for people like tourists, businessmen, people that want to go on vacation to understand basically areas that are more likely prone to terrorist attack. So to get started, the first thing we'll be doing is to load our Jupyter Lab in the Anaconda prompt. So I've already done that earlier. So after I must have loaded our Jupyter Lab in the Anaconda prompt, our browser pops up where all our codes will be written, and the first step is to load all the libraries that will assist us in running our exploratory data analysis. And some of the libraries that we are going to be using includes pandas, numpy, matplotlib, pyplot. Then we are going to use pickle, seaborn. So by the time you look at the first cell, that's where we loaded all our libraries. Then we move to the second cell where we are going to load the data sets into our Jupyter Lab. The data set has already been downloaded on my local drive with the name Global Terrorism DB 0718 dist.csv. So we can now take a look at some of the data being contained in the data set. So as you can see, this is a view of the data which we can run through to have an idea of what our data set contains. So after I've gone through the column names of the data set we have, I've been able to collate some of the necessary columns that I personally felt that might not uh, have any significant effect during the process of our analysis. And I've named them, I've collated them in a list with a variable name unwanted column. So after I've done that, the next thing is to drop those columns because we no longer need them. So that's why I now run the df.drop where our columns is equals to the unwanted column, and so that after we must have deleted them, uh, the notebook will be able to recognize that the data it will now be returning will be the data without all these columns. That's why we have in place is equals to true. So we can now look at the columns we have left after we deleted the column, and these are the column we have: I year, I month, I day, and so on and so forth. So we can also look at the shape of our data set. The shape basically tells us the number of rows and columns we have in the data set. And by the time we look at it, we have 181,691 rows and we have 59 columns. We can look at some basic information of our data set, and uh, Pandas has provided a function that does that for us, which is the info, which we can run on our data set. The info basically tells us about the number of non-null we have in our data set for each column and the data type. I'm merely looking at this. We have already seen that we have 181,691 rows. So we can use that to determine ahead if there are missing values in our data set. And as you can see, when we look at the alternative test, we have 29,011 data, which means there are missing data in this data set. Any data that does not have 181,691 rows means that it has a missing value in the data set. And as we can see from a brief view, there are missing values. Then aside that, we can also look at the statistics of our data sets, the descriptive statistics of our data sets, like the count, the mean, the standard deviation, the minimum value, the 25 percentile, the 50 percentile, the 75 percentile, and the maximum. That itself can give us an insight uh, for our data set. For instance, by the time we look at the year, we can see that the year runs from 1970 to 2017. So which means the range of data we have collected is from 1970 to 2017. Then we can look at the high months. Obviously, we have 12 months in a year. So which means that we have a minimum month of 0. Uh, then we have a maximum month of 12. And that itself calls for question, because we begin to ask ourselves, is it possible to have a month with zero label? So which means there are some necessary data cleaning we might have to do in the process of working through the notebook. Then by the time we also look at the ID, we see that we have a minimum of 0.1 and a maximum of 31, which is also the same issue with that of the month. So all those things needs to be looked into and see how possible we can clean those data sets. And basically what we have just done in looking at the statistics of the data sets using the describe function, uh, the statistics we are having is for quantitative data. We can also look at the statistics for qualitative data. And what do we mean by qualitative data? Qualitative data are data that are not represented in numbers or that cannot be used for calculations. So we can also look at the statistics, and for the statistics we can look at the count, we can look at the unique values, that is the distinct values, how many distinct values we have in the data set. Then we can also look at the top, which means the highest, the value that has the highest occurrence. Then we can also look at the frequency, that is how many times does it occur. So which means by the time we look at the first one, which is the country year, the count is 181,691. The distinct value we have in the country test is 205. Then the top, which means the highest existing value or the value with the highest frequency, is Iraq, and Iraq occurs 24,636 times. So we can also take a look at the others and gain some insights from that. Then after that, we can now go ahead to look at how many missing values do we actually have in each column. So which we can do using the df dot is na is like a query saying that how many non values or non number do we have, then sum it up and return a value. So which means in our I here we have zero missing value. By the time we look at the city, we have 434 missing values, and by the time we come to the core tree, by the time we look at the target tree, we have 180,516 missing values. So which means we also have to clean our data. We can also visualize the missing value using our heat map. So by the time we look at heat map uh, with the argument df dot is na, then we can set our cbar to false, so we can visually inspect where we have our missing values and what is the amount of missing values we have. So based on this visualization and the number of missing values we have to make a judgment call, and the judgment call I'm making here is that any value that has over 100,000 columns will be removed. And so here, to define the columns we are removing, we are making use of a list compression. So I'm running a list compression that x for x in df column, and I'm saying that if the df x dot is na dot sum is greater than 100,000, give me those columns, Then after that, I can now say that okay, drop column, then the column I want to remove, then in place will be equals to true. And after I've done that, then the next thing is to drop any row that has NA so that we can have a much more cleaner data, which is what we have run here, that df.drop NA in place is equals to true. After we've done that, I run a visualization to see if there are any missing values, and as we can see, there are no white space in between the data set, which indicates that they are not missing values. Then we can also run our df.isNA.sum so that we can also look at it in terms of numbers, and we can see that all we have here is 0, which is telling us that there are no missing values. Then after that, is hotkeyed. I also value usually range from some other column which I felt that the value is supposed to range from 0 because of the analysis, which is the weapon, which subtype 1, the summary, then we have the target subtype 1 underscore test. When we look at the column is hotkeyed, we have some existing value as -9. The same thing goes for vicinity. And when we look at the target column, we also have unknown. And all these values too are not useful, because by the time we look at is host keyed, the value is supposed to range from 0 to -1, so which means -9 is telling us that they don't have the actual value for that column, so which means we also have to remove all those column, which is what we have done in this cell. Then by the time we go to cell 18, we can now inspect our column if there is any negative value in our column, and that's why by the time we look at it, for the numerical data, there are no negative value existing in our column. And we can also do the same thing for column that categorical. We can check if there is any existing unknown in that data set, and as you can see, there is not any unknown in the data set. Then by the time we look at the shape of our data at the end of the day, we are left with 83,278 rows and 21 columns. Then after that, we have gone through a very long process cleaning our data, trying to make sure that our data is in good shape for the analysis. It's always good that you save your data so that you don't have to start running your code right from the very beginning. So to do that, I'm going to use the pickle option to save my data set as cleandf.pk. So to load my data back, I can use the panda option, which I can now say df, which is the name of the new file I'm loading, is equals to pd, which is our pandas dot read pickle, then the name of the file I want to read. Then I can inspect the file again to see what is going on. So the first visualization we are going to be looking here is to look at the rate of terrorist attack based on year. So that's the first thing we'll be looking at, and by the time we look at it from the statistics, we can see that the highest attack occurred in 2014 with over 12,000 attacks taking place, followed by 2015, followed by 2013, followed by 2016. Then we can also look at countries with the most frequent attack. To do that, I run this code using a pie chart. I'm sure that by the time you sit down to study the different line of code, you can come up with a reasonable explanation of how I've been able to arrive at this. And we'll see that in Iraq, we have the highest attack, followed by Pakistan. The attack that took place in Iraq is 31.6% of 100%. So which means it has the highest attack, followed by Pakistan, followed by Afghanistan. Then we have least attack in Egypt, Yemen, Somalia, and Nigeria. So that is the rate of attack. Then we can also look at how successful those attacks are in those different places. We can use the group by function, then you can look at the code so that you understand. But basically, you see that uh, the attack is more successful uh, in Iran, followed by Pakistan, Afghanistan, India, and Philippines. So those are the first five places where we have more successful attack. Then we can also visualize this also by looking at our plot to see how successful the attack is. Then we can also look at the rate at which weapon is being used when this terrorist attack is taking place. And we can see that out of 100, uh, explosive will always be used 59.8 times. Then firearm will be used 32.49, while chemical happens to be the lowest weapon being used in most attack. Then we can also look at the targets when attack is taking place. Who are the major targets that terrorists are always after? Then from the data, we see that uh, we have private citizen and property 25%. So which means out of 100, the likelihood of private citizen and property being attacked is 25%. Then for military, we have 17.7%. Then for maritime, we have 0.12%. Then we can also look at the hostage in terms of what is the tendency of a kid being held hostage. We can see that in India is very high. We have 0.15, followed by Afghanistan, followed by Iran, Pakistan, and Philippines. Well, these are the few perspective one can generate from this data. More and more perspective can also be generated from this data, and more insights can be gained from the data set. At this junction, I'll be rounding up by saying a big thank you for taking your time to listen to my presentation.